All right, we're going to look at some calculator questions or calculator section questions. Important to remember that even though it says graphing calculator required, you're probably only going to use your calculator on maybe half of these problems. So we'll try to point that out. All right, which of the following sequences converges? We do so many series convergence questions that sequence convergence questions are even easier. So make sure you see that distinction. A series, a to the n, is going to converge if the terms are heading towards some number. So simply you have to look at when is the limit as n goes to infinity, and does that equal a constant? That's my question. If it doesn't equal a constant of some kind, then we say it diverges, right? So let's go through each one at a time. The limit as n goes to infinity of 5n over 2 to the n minus 1, we should recognize as 5 halves. That is convergent. Limit as n goes to infinity of our second one, e to the n over n. This is an example of a top-heavy scenario, and so that one diverges. And limit as n goes to infinity of e to the n over 1 plus e to the n. This one, you could use L'Hopital's rule to see that you get repeated e to the n over e to the n over e to the n. So that limit is actually going to be 1, and that means that it converges. So it's nothing about the series. Notice there's no sum here. It's just the sequence. Does the sequence go to a number? Your first sequence goes to 5 halves. Your third sequence goes to 1. That makes 1 and 3 your converging sequences. All right, 77 describes a region and asks you to figure out the volume of that region. This is a time where a calculator may help a little bit, although you should probably be able to graph that and find the intersection points without. I pull it up on the calculator here just so we can look at it. But you have this linear function mixed with a quadratic function, which describes or defines an enclosed area. This intersection point is going to be important. It turns out to be 3. This one is also important, and it turns out to be 0. Again, you can find this quickly on your calculator. You could also set these equal to each other and solve that way. Spinning it around the y-axis, so let's do a little picture of this. I'm going to have a reflection that looks something like this. And I'm going to spin, spin, spin. You may notice an issue right here with your left boundary. Actually, it's your right boundary. Changes, right? And so doing this one by a disk method or ring method is actually problematic. So this is actually a shell method problem. One giveaway is that it's with respect to x, and if I did my rings, it would be with respect to y. So we want to remember our formula. It's going to be 2 pi x times the height, right? And I'll just write that as f of x dx. And all I really have to do is figure out the height, right? And my x values are going to go from 0 to 3. Right? If I drew a little cylinder in this picture, it would look like this. Right? And I'm basically building it out from the middle, and ultimately finding that length right there from here to here is what's key. So that f function turns out to be the top function for x minus x squared minus the bottom function, which is x. I end up with 2 pi integral from 0 to 3 of x times 3x minus x squared. That's 2 pi integral from 0 to 3 of 3x squared minus x cubed dx. Looking through my answers here, the one that matches that is E. Kind of a challenging question, but that's a shell method volume of revolution. Notice you don't have to do the work, it's just which one makes the most sense.